Okay, once again, afternoon, folks. This time around, we are tackling AS or A-level computer science, and in particular, we are interested in operating systems as well as language translators. I hope this series is going to be enlightening because we are going to be looking into various aspects or things that matter when we talk of operating systems, their importance on top of hardware. Uh, why do we need compilers? Why do we need interpreters? All those things are going to be tackled in detail. So we've got 2 points under operating systems. That's operating system itself as well as language translators. Now, of interest on operating systems, we are interested in checking why exactly does a computer system require an operating system. Issues such as processor management, memory management, file management, peripheral device management, input, output, you name it, security, and the user management. Uh, One other thing we'll look at is purpose of utility software. Which ones do we have in common in their purposes? Such as compression, defragmentation, encryption, antivirus with backup tools. We are also going to look into libraries and the benefits of using libraries such as DLLs, translators. We also want to look at the purposes of assemblers, compilers, and interpreters. And then we do a comparison of a compiler versus interpreter. Then we also look at the integrated development environment of various IDEs. So for a start now, we are now looking into why does one require a, an operating system? In other words, here we are targeting a computer. Why would a computer require one? So some of the reasons to look into, well, the operating itself, it needs to communicate with the hardware. So operating system is required because the hardware, computer hardware, cannot it cannot operate on its own. So in other words, you can say it cannot coordinate itself. So there is need for the communication between hardware components and software components. One other point is applications themselves, they need a platform to run. Applications need a platform to run. Applications such as Microsoft Word, the operating system itself, it needs that platform for it to run. Um, so there is a really importance for the operating system in the computer system. The user of the computer system requires an interface, so we need to communicate with the computer system. So user requires interface. So this is a platform where you can type in your instructions and the computer gives you feedback. And also the computer system needs to allocate resources safely and efficiently. So there is need for resource allocation efficiently. So that's done by an operating system. It knows this memory, how much is it required, has it been relinquished, which program can be given memory in terms of processing. One other importance of an operating system is to prevent conflict between programs. So sometimes there might be equal need uh, of a service. So the operating system, it does tasks such as which one gets which service at which period. So the operating system is also required because of the issues spoken about above. That's the reason why we need operating systems. So some of the key operating system management tasks. See, they are tasks that are performed by an operating system. These tasks involve the allocation of CPU time to processes. So it does allocation of system time or CPU time to processes, or CPU time to processes. In other words, each process has got its lifetime. So the CPU has to be instructed as to how much time can be allocated to a specific resource. Also, the operating system does scheduling of algorithm. So it schedules algorithms. These are steps followed by the computer system as it executes the program. So we have issues such as priority scheduling, scheduling. That's when you are determining which event has to be executed first, which method. We also have algorithms such as round robin, you name them. So these are all scheduling algorithms that might be performed by the operating systems. We also have memory management. The OS performs tasks as allocating, it allocates RAM, allocates the memory RAM to programs as they are being executed. So it allocates them the RAM to programs. Uh, so that's a part of memory management. It also tracks the usage of memory itself, tracks memory usage, how much memory is available, how much has been used. Is the CPU still able to handle the memory available to specific programs? It also does virtual, um, handles virtual memory and paging. So it does virtual memory and paging. So as part of memory management performed by the operating systems, we also have file management. So one of the purposes of operating system is to organize and manage, organize and manage the files. So in other words, we are looking at how documents or files are arranged within the computer system. So this, that's directories. These are some of the tasks of file management performed by the operating systems. It also manages read or write permissions. It manages read or write permissions. Who has got authority to alter data and all that, that is governed by the operating systems. It also maintains file metadata. So it maintains file metadata. Oh, those are some of the tasks performed by the operating system involving file management. Then, as we know that the operating system does control devices and the peripheral components connected to the computer system. So one of the tasks of the operating system is to communicate communicate with the hardware. Can we eject a USB? Can we open the drive? All those things are controlled or governed by the operating systems. So it also controls input or and output safely. So I'm sure we have seen points where the computer system is informing you that now is safe for one to remove a device which was connected or plugged to the computer system. Then the next aspect is security and user management. When we talk of security here, we are looking at user account. We talk of user account management. We are saying these are users stored within the computer system. We also look at the access rights of the users allowed to use the computer system. Um, which privilege does one have? That is governed by the operating system. And also the operating system itself, it does authentication, checking which user is allowed to access which files. Then next we are moving to utility software. Now its purpose is to support level tasks not performed by the operating system kernel. In other words, there are some tasks that are not directly performed by the OS kernel. So typical utilities where the um, uh, utility system can be engaged. Here we'll be interested in looking at, for instance, antiviruses. The utility system, antivirus softwares. They fall under the utility softwares that we're talking about. This defragmenter, we might be interested in reshaping this defragmentation, how to structure our drive where we store files and stuff. That is done by utility softwares. We might be interested in activities such as compression of files. Um, this does not directly need the operating system. There are some softwares that does that. Encryption software is another example of utility software. You want to hide your information from unauthorized users, one might require utility softwares. We might also talk of backup softwares, software that perform, uh, you know, construction of a backup or a copy of information that you have within your computer system. Also, we might look at disk repair. That is done by utility softwares. Maybe your disk has got bad sectors and stuff. You might need utility software. Some files or certain services or utilities. One needs um, what else can we think of? Well, firewall utilities is another one where we might need utility software. So firewall services, they require utility softwares. Then program libraries, which include DLLs. Our interest might be, what's the purpose of a program library? Where does it help us? We have spoken about the operating system, its benefits. We also spoke of the utility software. So this time around, we are on program libraries. So their purpose is to actually, save with pre-written and pre-tested code modules. So it's we have pre-written and pre-tested code modules and pre-tested code modules. Um, so here it looks like it says view on a programmer having to do all the required coding in first level form. So this is used by programs as program libraries. They are used by programs to avoid rewriting, to avoid rewriting. Like we are saying, you don't write everything from basic. You avoid rewriting common functions, so things that you use often. They are found within the program libraries. So we say common functions. So what's the benefit? We're talking about time, that as you are developing programs or typing, you are saved development time. So that's part of the saved development time, because this has been pre-configured for you. So yours is to simply import or invoke, then you use the service. One other advantage is it improves reliability. Reliability, because these are code snippets that have been tested thoroughly before deployed. And also there is encouragement of modularity. In other words, certain feature which is basically or which is used more often, you simply need to import, you use it, then done. So they also reduce or limit memory usage. So it reduces memory usage. In which way does libraries reduce memories? It's loaded only when needed. So it's only loaded when it is required. So it reduces memory usage by being loaded only when required. So that's part of benefits of libraries. Then we are looking at language translators. We have assemblers, we have interpreters, we have compilers. So starting with an assembler, it converts assembly language from the name itself. So this one, it converts assembly language, language which is next to machine language, to machine code. That's its purpose, machine code, which is instructions understood by the computers themselves. So this is mainly used for low-level programs or code. So this is low-level languages where we normally interested in either binary or hexadecimal instructions. Then the next one is a compiler. Well, this one is designed to do a translation or a conversion of high-level languages. So it translates high-level languages. When we say high level languages, here we are looking at language which is human readable. And this is done, high level program done at once to build up what's normally referred to as bytecode. So what will be produced here is an executable file. So when that translation is done, we produce an executable file, which can be transported from one device and run on another machine. Then with a compiler, this is one which performs instruction execution line by line. But still on the compiler, we are looking at other benefits to say a compiler, it gives us faster execution. Once the executable file has been built, it means now the processing of instruction becomes speedy. And this is important for software production. So it's good for software production. As I said earlier, if you're interested in development of bytecode, which can be migrated from one machine to another. And now talking about an interpreter, we are saying this is a system where instruction is executed line by line. So here on interpreter, we translate instruction line by line. So this instruction is translated and executed line by line. There is a benefit to that, especially when you are writing lengthy or long code. There is a bug. A bug is identified there and then. So that's one of the benefits we are looking at under interpreters, that this is useful on debugging software, because instructions are read line by line. So you are saved from getting trapped in multiple errors, because once an error is found, it's rectified or corrected there and then. So it's an advantage during software development. So there's no final code that needs to be executed, since execution is done line by line. So no final code needs to be executed. So no final executable table file is generated. So everything is done during the software development itself. So here we want to make a comparison of a compiler versus an interpreter. Compiler, we were saying with compiler, we need to generate our executable file, but with interpreter, we are dealing with errors line by line. So let's check the benefits of a compiler. It has got fast execution and also um, during compilation. So this execution is speedy during execution, but it happens after compilation. Now with an interpreter, though it executes an instruction line by line, but it is slower execution. So the execution time is lengthy, so slower execution. Then we're moving to another comparison there, where we are saying a compiler produces a file which is called an executable file. So compiler produces an executable file, which we normally refer to .exe. So it produces an executable file which is standalone. Otherwise, it can be shifted to another platform where it can be run, be it Mac or Linux, you name it. As long as that executable file has been generated, then it can be run on different platforms. Then with an interpreter, you see, every time you have to rerun the interpretation. So we need to just rerun on every execution, reinterpret every run. So that's an interpreter. Whenever you want to use the file or its results, you have to redo the process. Then with compiler, it is harder to re-engineer because it's run at once, so harder to re-engineer. Develop your program once it's done, because compilation sometimes is done once you have developed the entire system. So going back to the prior stages might be difficult. And with interpreter, it's easy to inspect because it's inspected line by line. So this one is easy to inspect. You can easily identify errors and fix them there and then. That's an interpreter. Now, with a compiler, it is good for software production, so that's good for distribution. Like I was saying earlier, that once bytecode is generated, it can be used on different platforms. So it's good for distribution if you are likely to share the product. But with interpreter is good for teaching or debugging. So this one here is good for teaching because you easily identify the errors or you want to locate errors, which is debugging. I think basically those are the comparisons we have between compiler and interpreter. With compiler, we have fast execution, interpreter is slow. Well, we produce an executable file, but with an interpreter, you need to rewrite or reinterpret for you to come up with the results. Also, with compiler, it's harder to re-engineer because compilation is done at once, but with an interpreter, it's easy to inspect because every instruction is verified once um, the code has been run. Now we want to look at the integrated development environment to say what do we expect from platforms where we write our code from. So a full IDE or an integrated development environment, it simply includes the following. Well, we have a code editor, which is an area where we type in our instruction. That's a code editor. It can be, well, we have various code editors like PyCharm, we have VS Code, you name them. Other purposes, it does syntax highlighting. When we say syntax highlighting, there are some preserved or reserved words which cannot be used as variables or any other predefined word. It can not be used in user uh, definition of instructions. Also, IDE, it does error diagnosis. So it also assists in fixing, it's identifying and fixing of errors. That is done by the IDE. You try and compile, it highlights the errors or points where the fault might be. And also it does auto-completion. You type in a familiar word, it gives you possible completion such that you can easily type or you can easily select the one that you want, which helps you or saves you time in typing all the instruction. So it works also as a debugger. It helps you in fixing errors. That's a integrated development environment. It helps you with breakpoints. If you want, say after a certain number of steps, can I check my errors? Also, you can do a step through where you're inspecting every instruction that you have typed. So all those are part of benefits of an integrated development environment. It also helps us with the version control support, tells us which version of the environment we are using that is found within an IDE. So yeah, it's very, very key to use an IDE whilst developing our softwares. It also supports us with building tools. So IDE gives us tools to build up our softwares and also tools to run. You have done your execution, you can play to see if the results are coming as expected. And also we have Project Explorer. You can easily navigate and check the projects that have been developed, which ones you're currently developing. So those are features of a typical IDE or integrated development environment. So next we want to try and from our discussion have a look at solutions that we might draw as we solve those problems highlighted above. So we'll meet in the second series as we think and discuss about solutions that match those given questions. Thank you.